Hi guys, here is Unit 6, Lesson 5, Factor Algebraic Expressions. Okay, so in the last unit, in the last lesson, we did the opposite. All right, we used the distributive property to expand on the expressions, right, when there was a parenthesis. Now we're going to do the opposite of that. All right, and I talked a little bit about it in my last video, but now this is our main focus. So first off, there's a couple definitions that we have not talked about. One of those is a constant. So a fixed term in an equation. So one example would be like x plus 3. 3 would be the constant, okay? Because 3 is always 3, right? The x represents, like, you could put other things in there and it could change the problem, whereas the 3, it's just always 3, right? That doesn't change. Greatest common factor, this should be a term that you've known for quite a while, but that's the largest number that goes into two or more numbers. And we're going to do examples of those right now, so if you're kind of like, I forget what that is, don't worry, I got you. So let's see here. First off, for example, so find the GCF of 21 and 15. So we're looking for the biggest numbers that go into both 21 and 15. If you really need to, you could make lists for both numbers, right? So 15, you could say, okay, 1 goes into 15, 3 goes into 15, 5, and 15, right? For 21, let's see, 1 goes in there, 2 doesn't go in because it's not an even number, but 3 will, 4, 5, 6, none of those do, but 7 does, and the number 21 itself. Okay, so those are all the numbers that, like, 15 can be divided by and get a whole number as your answer. These are all the numbers that 21 can be divided by and get a whole number as your answer. Okay, so what we're looking for is the largest number between both lists. In this case, that's the number 3, right? That's the largest number that matches for both of those. So the greatest common factor, you can say GCF equals 3. Okay, same thing with 9 and 36. Again, if you want to, make lists of them. Let's see, 1 goes into 9, 3, and 9. Those are the only numbers that go in where we can divide it and get a whole number as our answer. Then we have 36. Well, let's see, this one has quite a few more. 1 can go into it, right, because 36 goes into it. 2 can go into it. And you can even think, okay, what can I multiply 1 by to get to 36? 36. What can I multiply 2 by to get to 36? 18. What can I multiply 3 by to get to 36? 12. What can I multiply 4 by to get to 36? 9. And then let's see, 5 doesn't go in because it doesn't end in a 5 or a 0. And then the last one would be 6. 6 times 6 is 36. So this is my complete list of factors. So again, what I'm looking for is, what is the largest number that goes into both? And that's 9. And sometimes that happens. Sometimes it's the number itself, right? So in this case, 9 was one of the numbers that we were given, but it goes into 9 and it goes into 36. Okay? So we're going to do the same thing as that, but within expressions. So in this case, I have two numbers. One, I have a coefficient, that is a number like attached to a variable, okay, and I have a constant, right? But they can still have some things in common. I could divide both of those by a number. So with this, I'm going to look for, well, what is the greatest common factor between 6 and 15? Well, 6, let's see, 1 goes in, 6 goes in, 2, and 3. For 15, I've got 1 and 15, 3, and 5. What's the largest number between them, or what could we factor out? That would be the number 3. Okay? So, there's going to be several questions just like this, where it just says, find the GCF. Okay? And this is one of those. But we could take it a step further, because what we're focusing on in this lesson is factoring out values. So because both of these can be divided by 3, I could pull that out. There's my 3. And then write parentheses. Well, 3 times what gets me to 15? 5. So we would say 5q plus, and then 3 times 2 gets me to 6. Okay? So you could do this. This would be called factoring it out. To check your work, you could plug it right back in. Use the distributive property to put it right back in there. 3 times 5, well, yep, that gets me to 15q. Plus 3 times 2 gets me back to 6. Okay? And let's see here. I think, yeah, I've got 2 more problems set up for you. So this next one, it says factor 9z plus 18 using the greatest common factor. So again, we need to look for what do 9 and 18 have in common? What can they both be divided by? Which means, like, what are their common factors? So again, if you need to, set up your lists. When numbers get bigger, though, that's harder to do. So numbers that go into 9 are 1, 3, and 9. Numbers that go into 18, well, I've got 1 and 18. I've got 2 and 9. Oh, look at that. We can already tell which one is going to be biggest. But just to make sure we have a complete list, we could add in the 3 and the 6. Okay, so in this case, the greatest common factor would be 9. So this would be the answer. Like on your practice, it's going to ask you that. Okay, but we could, so that, what that means is that we can pull a 9 out, right? So if I'm dividing both of these by 9, well, 9 divided by 9 is 1, or I have 1z, or just z, right? How many z's do you see? Just 1. Okay, plus, and then 18 divided by 9 is 2. So this would be the factored version. All right? So it's good to have extra practice on those. All right, number 4. This is number 3 on your quick check. It says use properties of operations to factor 8w plus 16 using the greatest common factor. So we're just doing this. We're doing that exact same thing, but this time we have 8w plus 16. Well, if you need to, make your lists, right? You might not need to, which is a good thing, right? That means you're having more number sense. But the numbers that go into 8, we've got 1, 2, 4, and 8. 16, I have 1 and 16, 2 and 8, and 4. Okay, so the greatest number between both of them, there's that 8, so that, which means I can pull an 8 out. So I can say, okay, well, 8 and then parentheses, well, 8 divided by 8 is 1, so I'm left with 1w, or just w, plus, and then 16 divided by 8 is 2, so that would be your final answer. Okay, now, and again, check your work. 8 times w, if I distribute it back in, 8 times w is 8w, 8 times 2 is 16. All right, so that's what you're doing in this lesson. It's just a basic introduction to factoring, because that's going to help us when we simplify more expressions later. Okay, as always, reach out if you need extra support.